Standing in the shadow of a megalith, you can't help but feel the weight of time pressing down on you. These massive stones, some weighing as much as 50 tons, were carved, moved, and placed with precision by hands that belonged to a world thousands of years removed from ours. Yet here they stand silent, imposing, and brimming with unanswered questions. What if these ancient monuments weren't just ritual sites or burial grounds? What if they were the first textbooks, the original observatories, the earliest experiments in science and engineering? Today, we're peeling back the layers of time to uncover the secrets hidden in the stone secrets that might rewrite our understanding of human ingenuity. Think about the last time you looked up at the night sky, tracing the constellations with your finger. Now imagine doing that without telescopes, without star charts, without even the basic tools we take for granted. That's exactly what the builders of megaliths like Stonehenge or the Karnak stones did. These structures aren't just random piles of rock. They're carefully aligned with the movements of the sun, moon, and stars. Some mark solstices with pinpoint accuracy, while others seem to map out celestial events with a sophistication that rivals modern astronomy. How did ancient people, with no written language or advanced technology, achieve such precision? The answer might lie in the stones themselves, serving as both monuments and measuring devices, capturing the rhythms of the cosmos in their unyielding grip. But the mysteries don't stop there. The engineering behind these megaliths is just as baffling. How did prehistoric societies transport these colossal stones across miles of rugged terrain? How did they lift them into place with nothing but ropes, logs, and sheer human determination? The techniques they used, some of which we're still piecing together today, hint at a level of teamwork and problem-solving that rivals our modern projects. And perhaps most intriguing of all, why go to such lengths? Was it just for ceremony, or were these megaliths part of something bigger? A way to pass down knowledge, to teach future generations about the world and their place in it. As we journey through the secrets in the stone, we'll explore how these ancient wonders might have been humanity's first steps into science, turning observation into understanding and curiosity into legacy. This isn't just a story about rocks, it's a story about us. Megaliths aren't just big rocks, they're puzzles carved in stone, left behind by people who lived in a world we can barely imagine. Picture a single standing stone taller than a two-story house, dragged from miles away and planted vertically into the earth with nothing but muscle and ingenuity. Now multiply that by hundreds, arranged in perfect circles, rows, or towering tombs. These structures stretch from the windswept moors of Britain to the sun-baked plains of Turkey, each one a testament to a shared human impulse to build something that outlasts generations. But what's truly mind-bending isn't just the scale, it's the precision. Take the dolmens, those table-like structures made of a massive capstone balanced on upright stones. The angles are so exact, the fits so tight, you couldn't slip a piece of paper between them. How did ancient builders achieve this without levels, blueprints, or even metal tools? Then there's the placement. Many megaliths aren't random, they're meticulously positioned to capture the first light of the winter solstice or frame the rising moon at a specific time of year. The Callanish stones in Scotland, for example, form a cross-shaped pattern that aligns with the lunar cycle, marking points in the sky with eerie accuracy. This isn't guesswork, it's deliberate, repeated observation turned into permanent architecture. And that's where things get really interesting. If these stones were just tombs or temples, why go to such lengths to track celestial events? Unless, of course, they were doing more than worshipping, they were measuring, calculating, documenting. The deeper you dig into megaliths, the more they blur the line between sacred and scientific. Consider the Great Dolmen of Zambujeiro in Portugal, its chamber designed to amplify sound in a way that suggests ritual, or perhaps an early experiment in acoustics. Or the Karnak stones in France, over 3,000 standing stones arranged in rows that might have functioned as a giant calendar or even a primitive computer, encoding information in their spacing. These aren't just monuments, they're snapshots of a time when humanity was first learning to read the world like a book, using stones as pages. So what were they, really? The truth might be all of the above: tombs that doubled as classrooms, temples that functioned as observatories. In a world without writing, maybe these colossal stones were the original hard drives, storing knowledge in their positions, their alignments, their very weight. Every megalith is a conversation across millennia, whispering secrets about how our ancestors turned wonder into wisdom, one stone at a time. From the windswept plains of Europe to the remote islands of the Pacific, megaliths stand as silent witnesses to a phenomenon that transcends borders and cultures. The towering moai of Easter Island, with their solemn gaze fixed inland, share an uncanny kinship with the sprawling alignments of Karnak stones in France, though separated by oceans and millennia. How is it that societies with no apparent contact erected such similar monuments? The answer might lie in something fundamental to humanity itself, an innate drive to mark our place in the world, not just with words but with weight. Take the dolmens of Korea's Ganghwa Island, their massive capstones perched like giants' tables, or the haunting stone circles of Senegal's Washu region. These structures echo designs found in Ireland's Boyne Valley and India's Deccan Plateau, despite continents dividing their builders. Some researchers argue this points to a lost network of ancient knowledge exchanged along forgotten trade routes. Others believe it's evidence of parallel innovation, that when faced with the same existential questions, humans from different corners of the Earth arrived at eerily similar solutions. The diversity in function deepens the intrigue. In Malta's hypogeum, subterranean chambers resonate with sound frequencies that suggest ritual or even early acoustic experimentation. Meanwhile, Ethiopia's Tia stones stand sentinel over graves, their cryptic carvings hinting at stories we've yet to decipher. And then there's Peru's Sehuite stone, its surface a maze of carved channels and depressions that some theorize was a scale model for water management. What unites these sites isn't just their scale, but their purpose. Each seems to be a physical manifestation of human curiosity, a way to interact with forces as vast as the sky or as intimate as a whisper. Could climate or geography explain this global impulse? In regions like Britain's Orkney Islands, where timber was scarce, stone became the logical canvas for expression. But in lush, forested areas like Indonesia's Nias Island, megaliths still rise, defying practical explanations. Perhaps the true thread connecting them isn't material necessity, but something more profound, a universal yearning to reach beyond the ephemeral, to carve meaning into the earth itself. Whether serving as calendars, tombs, or communal gathering points, these stones speak a language older than writing, one etched not in ink, but in alignment, weight, and endurance. The more we study these sites, the clearer it becomes. Megaliths aren't just local anomalies, but chapters in a global story of human ingenuity. From the desert monoliths of Arabia to the moss-covered menhirs of the Caucasus, they challenge us to rethink what ancient societies were capable of and what they hope to tell us across the ages. Every stone, in its way, is a question, not just how they built, but why they felt they must. Stonehenge isn't just a ring of ancient stones, it's a time machine, an astronomical device frozen in the landscape. Picture standing in the center of that iconic circle as dawn breaks on the summer solstice. The first rays of sunlight slice perfectly between the uprights of the great trilithon, illuminating the altar stone like a spotlight. This isn't a coincidence. The entire structure is engineered to capture these celestial moments with breathtaking precision. But how, without telescopes or written records, how did Neolithic people design a monument that functions like a stone-built calendar, tracking the sun's path down to a fraction of a degree? The answer lies in patient centuries of it. Generations of sky watchers likely passed down observations, noting how the sun's rising point shifted along the horizon with the seasons. Over time, patterns emerged. The solstices, when the sun seemed to pause before reversing direction, became anchor points in their understanding of time. Stonehenge's builders didn't just mark these events, they encoded them into architecture. The heel stone, for example, aligns with the summer solstice sunrise, while the station stones form a rectangle that frames the moon's extreme positions in its 18.6-year cycle. This isn't just ritual, it's rigorous, repeatable science carved into the earth. What's even more striking is the scale of coordination this required. Transporting the blue stones from Wales, over 150 miles away, suggests a society capable of long-term planning and collective effort. But here's the real twist: some stones at Stonehenge aren't local either. The Saracens, those towering megaliths weighing up to 30 tons, were dragged from 20 miles distant. Why go to such lengths? Because location mattered. The site sits on a chalk plateau with unobstructed sightlines to the horizon, making it an ideal natural observatory. Every stone placed, every alignment calculated, served a dual purpose, honoring the cosmos while harnessing its rhythms. This raises a provocative question. Was Stonehenge a prehistoric research center? The Aubrey holes, a ring of pits encircling the monument, may have held wooden posts used to predict lunar eclipses. Meanwhile, the Y and Z holes, concentric rings dug later, suggest refinements to their celestial models. If true, this wasn't just a place of worship. It was a laboratory where early scientists tested and updated their understanding of the heavens. The implications are staggering. If Neolithic Britons could predict eclipses or measure the year's length with near-modern accuracy, our timeline for the birth of astronomy might need rewriting. These builders weren't just stacking stones, they were mapping time itself, turning a windswept plain into a cosmic clock. And that clock still ticks today, its silent gears made of earth and sky, whispering secrets across 5,000 years. Imagine a tomb so precisely engineered that for just 17 minutes a year, as the winter solstice sun crests the horizon, a narrow beam of golden light creeps down a 60-foot stone passageway to illuminate a chamber untouched by daylight for the other 364 days. This isn't science fiction, it's Newgrange, a 5,000-year-old masterpiece hidden beneath a grassy mound in Ireland's Boyne Valley. Built 3 centuries before the pyramids and a millennium before Stonehenge, this passage tomb isn't just a burial site, it's a solar calculator carved from earth and stone. The roof box, that slit-like opening above the entrance, functions like a Neolithic camera shutter, capturing the year's weakest sunlight and funneling it into the heart of the structure with pinpoint accuracy. What's staggering isn't just the alignment, it's the intentionality behind it. The builders didn't just observe the solstice, they engineered a way to bottle its light. The passage angles upward at just the right degree to catch the sun's low trajectory in midwinter, while the corbelled roof with its overlapping stones prevents collapse under the mound's weight. This level of precision implies generations of accumulated knowledge, passed down through oral tradition long before the invention of writing. But why go to such lengths? The answer might lie in the chamber's eerie acoustics, where echoes reverberate at frequencies that some researchers believe could induce altered states of consciousness. Combined with the solstice light show, Newgrange may have been a multisensory ritual space, part observatory, part cathedral, part laboratory for exploring the boundaries of perception. Then there are the carvings. Spirals, zigzags, and concentric circles cover the stones, their meanings lost to time. Some speculate they map celestial events, while others see them as symbolic representations of the afterlife. The triple spiral inside the chamber, illuminated only during those precious solstice moments, might have served as a Neolithic PowerPoint slide, a visual lesson about cycles of death and rebirth tied to the sun's journey. What's truly humbling is realizing Newgrange wasn't built in isolation. It's part of a sprawling ceremonial landscape that includes nearby tombs like Noth and Douth, each with their own solar alignments. Together, they form a prehistoric science park where observations of the heavens were etched into the land itself. This wasn't just architecture, it was humanity's first attempt to weave time, light, and stone into a single enduring truth. And 5,000 years later, as modern visitors crowd the chamber to witness that fleeting solstice light, the stones still whisper their ancient lesson: look up, measure, remember. Buried beneath the dusty hills of southeastern Turkey, Gobekli Tepe shatters every assumption we have about the dawn of civilization. This sprawling complex of circular enclosures, each anchored by massive T-shaped pillars carved with leaping foxes, snarling lions, and coiled snakes, wasn't built by farmers in a settled society. It was crafted by hunter-gatherers, a full 6,000 years before the wheel or writing appeared. That fact alone turns history on its head. We've always assumed that agriculture came first, that only after securing steady food supplies could humans afford the luxury of monumental architecture. But Gobekli Tepe flips that script entirely. Here, it seems, the sacred came before the sown. The scale is staggering. Some pillars weigh over 16 tons, quarried from bedrock half a mile away, and raised without beasts of burden or metal tools. The precision is even more baffling. Pillars slot into sockets carved into limestone floors, their surfaces adorned with intricate reliefs that still retain traces of pigment. What drove nomadic people to invest so much labor in a site that shows no signs of permanent habitation? There are no hearths for cooking, no storage pits for grain, just these eerie circles of stones that seem to whisper of rituals lost to time. But look closer and patterns emerge. Many pillars depict animals not just as art but as a kind of code. Vultures stretch their wings across multiple stones, their bodies fragmented in a way that suggests storytelling or celestial symbolism. Pillar 43, dubbed the Stone of the Underworld, shows a scorpion, a vulture, and a headless man, a scene some interpret as an early depiction of death and the afterlife. Others see something more practical, a prehistoric zoo recording species for future generations, or even a star map with animals representing constellations. The most tantalizing clue lies in the architecture itself. The enclosures aren't randomly arranged, they're aligned with the night sky. One particular circle's central pillars frame the rising of Sirius, the brightest star in the heavens, while others may track the movements of the Pleiades. This isn't just decoration, it's deliberate, repeated observation etched into stone. Could Gobekli Tepe have been a kind of Neolithic university, where shamans or early scientists gathered to study the heavens and pass down knowledge? What's clear is that this site rewrites the story of human progress. If hunter-gatherers could organize themselves to build something this sophisticated, then perhaps the spark of civilization, of religion, science, and art didn't come from the practical needs of farming, but from something deeper, a shared hunger to understand the world and our place in it. The stones of Gobekli Tepe don't just mark the birthplace of the temple, they might mark the moment humanity first looked up at the stars and dared to ask, why? Standing on the slopes of Rono Roroku, the volcanic crater where Easter Island's moai were carved, it's impossible not to marvel at the sheer audacity of these statues. Towering as high as 33 feet and weighing as much as a small whale, these stone giants were somehow transported miles across rugged terrain without wheels, without draft animals, without anything but human hands and ingenuity. For centuries, the prevailing theory was simple: ropes and logs. Teams of islanders supposedly dragged the moai horizontally on wooden sledges, a method that seemed plausible until researchers actually tried it. The result: disaster. Replicas gouged deep tracks into the earth, damaging both the statues and the landscape, something archaeologists don't see in the historical record. So if they weren't dragged, how did these multi-ton monoliths cross the island? The answer might lie in a technique as elegant as it is unexpected: walking. Picture this: a moai tilted slightly forward. Its center of gravity shifted so teams of rope pullers could rock it side to side, inching it forward with each sway. This isn't just speculation. Experiments led by researchers like Terry Hunt and Carl Lipo demonstrated that as few as 18 people could walk a 10-ton replica upright, guided by a system of ropes and rhythmic pulls. The statue's design even seems tailored for this method. Their D-shaped bases and forward-leaning posture act like natural pivots, turning each nudge into momentum. But here's the twist: this technique leaves almost no trace. No grooved paths, no shattered statues, just the occasional toppled moai along ancient roads, as if they paused mid-stride. What's even more remarkable is the physics at play. Moving a statue upright reduces friction dramatically compared to dragging it horizontally. The moai's curved bellies and sloping backs aren't just artistic choices, they're engineering solutions, distributing weight to prevent cracking during transport. This wasn't brute force, it was applied mechanics, a dance between human coordination and stone. And the islanders didn't stop there. They managed resources with startling precision, using every inch of the island's limited palm forests to create ropes and lever-like devices called parbuckling ramps to hoist the statues onto their ceremonial platforms, or ahu. The real lesson of the moai isn't just how they moved, but why they went to such lengths. These weren't vanity projects, they were living connections to ancestors, embodiments of community and belief. Each statue erected was a testament to cooperation, a feat requiring hundreds of hours of coordinated labor. In a place as isolated as Easter Island, where every tree and rock was precious, the moai stand as proof that innovation isn't born from abundance, but from necessity. They challenge us to rethink what ancient societies could achieve, not with magic or mystery, but with observation, patience, and a deep understanding of the world around them. And somewhere in that volcanic quarry, half-carved moai still cling to the rock face, as if whispering the next chapter of their story to anyone willing to listen. Perched high in the Andes, Machu Picchu's stones fit together so perfectly you couldn't slip a credit card between them, yet not a drop of mortar holds them in place. This isn't just craftsmanship, it's architectural genius refined over generations. The Incas didn't just stack rocks, they engineered them like three-dimensional puzzles, each a regularly shaped block carved to interlock with its neighbors in a way that flexes and shifts during earthquakes instead of crumbling. This technique, known as ashlar masonry, turns entire walls into shock absorbers, dissipating seismic energy through subtle movements. Walk through the citadel's sacred district, and you'll see stones with up to 32 distinct angles on a single block, each facet painstakingly shaped to marry perfectly with the next. The result, structures that have weathered 5 centuries of tremors while modern buildings nearby lie in ruins. But how did the Incas achieve such precision without iron tools, wheels, or even a written language to record their methods? The answer might lie in their reverence for trial and observation. Take the Temple of the Sun, where curved walls mimic the natural contours of the bedrock beneath them. This wasn't just aesthetic, it was practical, anchoring the structure to the mountain itself. Or consider the iconic Intihuatana stone, its angles calibrated to cast no shadow at noon during the equinoxes. These weren't random experiments, they were the fruits of meticulous, repeated testing, where failure meant collapsed walls and crushed workers. Over time, the Incas distilled these hard-won lessons into rules of thumb, passed down through generations of masons. Yet there's tantalizing evidence they went beyond mere empiricism. The trapezoidal doors and windows found throughout Machu Picchu aren't just stylistic choices, they're seismic innovations. Wider at the base than the top, these shapes redistribute weight away from vulnerable corners during quakes. Even more striking are the L-shaped stones found at critical junctions, acting like natural braces. This level of sophistication suggests the Incas didn't just stumble upon these techniques. They understood, at least intuitively, principles of load distribution and harmonic damping that modern engineers articulate with equations. Was this formalized science? Probably not as we know it, but in a civilization where architecture was sacred, where stones were considered living beings, the line between ritual and engineering blurred. The same hands that shaped temples to honor the sun also calibrated them to survive its fury. Machu Picchu stands as a testament to what happens when keen observation meets necessity. Not just buildings, but stone-born wisdom that outlasts empires. Stretching across nearly 2.5 miles of Brittany's coastline, the Karnak alignments don't just dominate the landscape, they defy comprehension. Over 3,000 standing stones, some twice as tall as a person, arranged in eerie parallel rows like soldiers frozen mid-march. Unlike the ringed formations of Stonehenge or the towering tombs of Newgrange, Karnak stones seem to follow a different logic, one that's less about enclosure and more about alignment, as if tracing invisible lines across the earth. But lines to where? Look closer and patterns emerge. The stones aren't uniform, they're graded by height, with the tallest megaliths to the west gradually shrinking as the rows march eastward. This isn't random. Researchers like Alexander Thom proposed that these rows functioned as a colossal sighting device, where the varying heights created artificial horizons to track the moon's extreme rising and setting points. The moon doesn't follow the same path every night over 18.6 years. It swings between northern and southern extremes, and Karnak's rows might have been a Neolithic spreadsheet, recording these subtle shifts in stone. Imagine standing at one end of the alignment as the full moon hovers just above a distant menhir, its light threading the gaps between stones like a celestial needle. For a culture without writing, this wasn't just observation, it was data storage. The scale of labor involved speaks volumes. Moving and erecting thousands of stones, some weighing over 50 tons, required coordination spanning generations. This wasn't a project born of superstition alone. It suggests a society deeply invested in understanding cyclical time. The nearby tumulus of St. Mitchell, a massive burial mound overlooking the alignments, offers a clue. Inside, artifacts reveal trade networks stretching from Spain to the British Isles, proof that Karnak's builders were connected to a wider world of ideas. Could the stones have been a meeting point, not just for rituals, but for knowledge exchange? Then there's the mystery of the Camarillo fan, a section where the rows curve abruptly, as if redirecting attention to a specific point on the horizon. During the winter solstice, the setting sun aligns perfectly with this bend, painting the stones in fiery light. Coincidence unlikely, but here's the twist: Karnak's purpose might have been multifaceted. The same stones that tracked lunar cycles could have doubled as territorial markers or pilgrimage paths, proof that ancient science rarely fit into neat modern categories. What lingers most isn't just the how of Karnak, but the why. In a world where survival depended on reading nature's cues, these stones were more than monuments, they were tools. Tools to predict tides, to time plantings, to navigate by the stars. They remind us that science didn't begin in laboratories. It began with stones and sky, and the relentless human urge to make sense of both. High in Lebanon's Bekaa Valley, the stones of Baalbek don't just whisper of lost civilizations, they shout. Here, beneath the soaring columns of Rome's Temple of Jupiter, lies a foundation so baffling it makes even the grandest Roman engineering look like child's play. The Trilithon, 3 monstrous blocks each weighing around 800 tons, form a platform that defies logic. But it's the nearby Stone of the Pregnant Woman that truly staggers the mind, a single block weighing in at over 1,000 tons, roughly the equivalent of 200 elephants. How does something that massive even get quarried, let alone lifted into place? The Romans, master builders in their own right, repurposed these megaliths for their temples, but the truth is far stranger. Carbon dating and tool marks suggest these stones were cut and positioned at least 2,000 years before Rome's rise by a culture whose name and methods have vanished from history. The precision is jaw-dropping, edges so straight they rival modern laser-cut stone, joints so tight you can't slide a razor blade between them. And then there's the quarry half a mile away, where the Stone of the Pregnant Woman still lies partially attached to the bedrock. The trenches around it reveal something eerie. The builders didn't just chip away at the stone, they undercut it, leaving a thin layer beneath that could be cracked free with wooden wedges and water. This isn't brute force, it's physics applied with surgical precision. Transporting these behemoths is an even greater puzzle. Even today, with cranes and flatbed trucks, moving a 1,000-ton block would be a logistical nightmare. Yet somehow, ancients dragged these stones uphill over uneven terrain, possibly using a system of wooden rollers, sledges, and levers techniques that would have required hundreds of workers coordinating with near-military discipline. But here's the kicker: the foundation stones aren't just stacked, they're interlocked with deep notches and protrusions, like a giant's Lego set. This suggests the builders weren't just strong, they were thinking generations ahead, engineering for earthquakes and shifting ground. The real mystery isn't just how they did it, but why. Baalbek sits at the crossroads of ancient trade routes, a place where cultures collided and knowledge could have been exchanged. Some researchers point to local legends speaking of a race of giants, while others speculate about lost technologies or forgotten schools of advanced masonry. But perhaps the simplest explanation is the most profound: that human ingenuity, when fueled by necessity and communal purpose, can achieve the seemingly impossible. Every groove in those stones isn't just a mark of tools, it's a fingerprint of ambition, a testament to what happens when curiosity and perseverance carve their will into the earth. And that's a lesson that echoes far beyond Baalbek's weathered stones. Buried in the sands of Egypt's Sahara, a circle of weathered stones tells a story far older than the pyramids. Nabta Playa, a remote basin that was once a seasonal lake, holds what might be humanity's first astronomical observatory, a ring of megaliths erected over 7,000 years ago by cattle herders who tracked the heavens with nothing but patience and stone. Unlike the towering monoliths of Stonehenge, these slabs are modest in size, but their arrangement speaks volumes. One stone leans inward, pointing directly to the summer solstice sunrise, while others frame the positions of key stars like Sirius and Orion's belt. This wasn't random veneration of the sky. It was methodical, deliberate science carved into the desert floor. What's astonishing isn't just the precision, it's the context. These weren't city dwellers with scribes and calendars, but nomadic people who followed the rains. Yet they invested generations in stacking and aligning these stones, embedding celestial knowledge into the landscape. Nearby, archaeologists found carved stones resembling cattle, a clue that these early astronomers might have used the stars to predict seasonal migrations and water sources. The implications are staggering. Long before Babylon or Greece formalized astronomy, hunter-gatherers were mapping the cosmos with nothing but memory and megaliths. But Nabta-Playa isn't alone. On the other side of the world, in what's now Wyoming, the Bighorn medicine wheel follows a similar blueprint. A spoked circle of stones aligns with the summer solstice and the rising of bright stars like Aldebaran. Built by Plains Indians centuries later, it shares Nabta's purpose, a fusion of survival and spirituality, where tracking the stars meant predicting buffalo movements or planting seasons. The parallels are uncanny, and they hint at something universal. From Africa to the Americas, cultures with no possible contact arrived at eerily similar solutions, turning stones into silent teachers of celestial mechanics. This raises a provocative question. Was astronomy invented multiple times, or does it spring from something innate in us? The builders of these sites didn't need telescopes to notice patterns, just keen observation passed down through generations. A child watching the same star rise over the same stone year after year would eventually grasp its rhythm. Over centuries, that accumulated wisdom hardened into tradition, then into architecture. The megaliths didn't just mark the sky, they made knowledge tangible, a way to freeze the cosmos in place so future generations could learn without starting from scratch. The real revelation isn't that ancient people studied the stars, it's how deeply they understood them. At Ireland's Loughcrew Cairns, a 5,000-year-old tomb's interior is illuminated only at sunrise during the equinoxes, a phenomenon requiring precise alignment. In Peru, the 13 towers of Chanquillo form a jagged horizon line that tracks the sun's yearly journey like a stone sundial. These aren't crude attempts, they're refined systems, proof that our ancestors didn't just worship the sky, they dissected it, measured it, and built monuments to hold its secrets. Perhaps the most humbling thought is this: beneath the surface of every primitive society lies a legacy of rigorous observation. The first scientists weren't robed scholars in libraries, but hunters and herders who turned standing stones into textbooks. Their legacy isn't just in the alignments we can still see today, but in the unbroken chain of curiosity that connects their world to ours, a reminder that science begins not with equations, but with looking up and wondering why. The stones don't just stand, they calculate. Scattered across ancient sites from Scotland to Sumatra, megaliths whisper a language of angles and ratios, their alignments tracing geometric secrets that predate Euclid by millennia. Take the Great Pyramid's proportions, echoing the golden ratio, that mystical number where the whole relates to the larger part as the larger part relates to the smaller. But here's the twist: the same ratio appears in much older structures like Ireland's Newgrange, where the entrance passage divides the tomb's interior in eerily precise harmony. Coincidence, maybe, but when you find identical patterns separated by oceans and centuries, it starts to feel like a hidden curriculum in stone. Then there's the Pythagorean theorem, or at least its shadow. At Britain's Stonehenge, the spacing between stones forms right-angled triangles with sides matching whole number ratios, like 3, 4, 5 or 5, 12, 13. These aren't random. They're what mathematicians call Pythagorean triples, combinations that create perfect right angles essential for aligning structures to celestial events. The catch: these triples appear in megalithic sites over 2,000 years before Pythagoras was born. Did ancient builders stumble upon these ratios through trial and error, or did they grasp principles we've since branded with Greek names? The evidence deepens when you examine smaller details. The cup and ring marks carved into stones from Scotland's Kilmartin Glen to Portugal's Coa Valley aren't just art, they might be early blueprints. Some researchers argue these concentric circles and radiating lines encode geometric relationships like the vesica piscis, the almond-shaped space where two overlapping circles meet. This shape, sacred in later traditions from Christianity to alchemy, appears repeatedly in megalithic carvings, suggesting an intuitive grasp of the intersections between sacred and mathematical space. But here's where things get contentious. Without written records, proving intentionality is like trying to reconstruct a symphony from a single note. Skeptics argue that geometric patterns emerge naturally, stack enough stones, and some will inevitably form pleasing ratios. Yet at sites like Malta's Tarxian temples, the floor plans reveal recurring pentagonal symmetries, a shape far harder to justify as accidental. And in Orkney's Micho, the entire chamber aligns so precisely with the winter solstice sunset that even skeptics concede the builders must have used some form of standardized measurement. What's undeniable is this: whether by instinct or intention, megalithic cultures embedded mathematical truths into their monuments. The Breton menhirs arranged in fractals, the spirals of Ireland's Noth that mirror galactic curves, these aren't just decorations. They're proof that long before chalkboards or textbooks, humanity was already speaking the universal language of numbers, etching its grammar into the bones of the earth. And every time we decode another alignment, another ratio, we're not just uncovering ancient knowledge, we're relearning a truth as old as the stars, that the universe doesn't just move, it counts. Deep in the darkness of Malta's Hal Saflieni hypogeum, a whisper can travel across 3 levels of carved chambers and arrive at your ear as clear as if the speaker stood beside you. This underground labyrinth, older than the pyramids, isn't just a tomb, it's a prehistoric concert hall. Certain niches resonate at 110 Hz, a frequency that studies suggest can alter brain activity, inducing trance-like states. Coincidence or evidence that 5,000 years ago, people weren't just building with stone, they were composing with it. Across Europe, megaliths hum with hidden acoustics. Ireland's Newgrange, with its corbelled roof, amplifies rhythmic chanting into a thunderous drone. The rollright stones in England produce eerie metallic pings when struck, as if the rocks harbor hidden bells. But the most striking example might be Peru's Chavin de Huanta, where labyrinthine tunnels funnel the roar of an underground river into a soundscape so unsettling, archaeologists believe it was used to simulate the voice of deities during rituals. These aren't random quirks of geology, they're too consistent, too deliberate. The builders seem to have selected stones not just for their size or shape, but for their sonic properties. Modern experiments reveal just how sophisticated this ancient acoustics knowledge might have been. At Scotland's Ring of Brodgar, researchers found that standing stones absorb low frequencies while reflecting higher ones, creating natural sound filters. Strike 2 rocks at opposite ends of the circle, and the tones interact in ways that mimic modern noise-canceling technology. Even more remarkably, some Karnak stones in France emit ultrasonic frequencies when rubbed, inaudible to humans, but detectable by animals. Could these have been prehistoric dog whistles used to summon or repel wildlife? The implications rewrite our understanding of early science. These cultures didn't just see stones as passive objects, they treated them as instruments, tuning them to interact with sound waves in predictable ways. At Spain's La Peña de los Enamorados, cave paintings cluster in chambers with the strongest echoes, suggesting art and acoustics were intertwined. In India's Vijayavattala temple, pillars sing when tapped, producing precise musical notes that still align with classical ragas today. What emerges is a portrait of Neolithic people as both engineers and composers, shaping landscapes into resonant chambers where physics met metaphysics. Whether used to enhance communal rituals, transmit messages across distances, or commune with the unseen, these sonic megaliths prove our ancestors weren't just stacking rocks. They were orchestrating experiences, using the very bones of the earth as their instrument. And in their echoes, we might just hear the birth of music itself. Moving a 30-ton block of granite across miles of uneven terrain sounds like the setup for a myth, but for ancient builders, it was just another day's work. Take Egypt's unfinished obelisk, a colossal stone shaft abandoned in its quarry. Had it been completed, it would have weighed nearly 1,200 tons, more than 2 jumbo jets. The techniques used to transport such monoliths weren't magic. They were masterclasses in applied physics. Workers likely slid stones atop wooden sledges, greasing the path with water or mud to reduce friction, a method proven effective in modern experiments. At Aswan, archaeologists found traces of these ancient lubrication highways, where the combination of slick clay and rhythmic pulling could move a statue the length of a football field in under an hour. But sledges were just the beginning. For vertical lifts, builders employed counterweight systems that would make modern engineers nod in respect. At Peru's Ollantaytambo, massive pink granite slabs were hauled up a steep mountainside using terraced ramps and levering devices. The key: balance. By suspending stones in rope cradles and using log pivots, workers could walk blocks upward inch by inch, redistributing weight with each tug. Similar methods appear in Japan's Baalbek-sized Ishi no Hoden, a 2-story tall monolith perched on a hillside with no clear path to its resting place. The solution, probably a combination of earthen ramps and Kagure Ishi rounded stones placed beneath the block like permanent rollers, reducing drag over long distances. The real genius lies in adaptation. In Iceland's lava fields, where wood was scarce, Vikings transported 10-ton basalt columns by freezing them into sledges of ice, harnessing winter as a tool. Meanwhile, on Easter Island, the Rapa Nui may have used a technique called parbuckling, where ropes wrapped around upright moai allowed teams to rock them forward in a controlled stumble. These weren't one-size-fits-all solutions. They were tailored responses to local materials and terrain, proving that ancient engineers didn't just copy, they innovated. What unites these methods is their elegant simplicity. No cranes, no hydraulics, just an intimate understanding of weight, leverage, and teamwork. When French researchers attempted to replicate the transport of a 250-ton stone using only Neolithic tools, it took 40 people just to rotate the block. Yet ancient crews moved heavier stones routinely, suggesting their secret wasn't just technique, but organization. Seasonal work crews coordinated pull patterns, even rhythmic chanting to synchronize effort. These invisible social technologies were as vital as the wooden rollers. The lesson etched into these stones isn't about brute force, it's about observation. Someone, somewhere, noticed that a round log could turn dragging into rolling. That wet mud reduced friction better than dry sand. That a team pulling in unison could achieve the impossible. These weren't just construction tricks. They were the first equations in humanity's long dialogue with physics, written not on parchment, but in the language of movement and stone. And every megalith that still stands today is a testament to that quiet, relentless conversation between problem and solution. carved into the granite face of a 4,000-year-old standing stone in Scotland's Kilmartin Glen. A spiral winds inward like a frozen whirlpool. Nearby, a crescent moon and a series of dots curve across the rock's surface. At first glance, these might seem like mere decorations, but look closer and patterns emerge. The dots mirror the phases of the moon, while the spiral's coils align with the sun's path during solstices. This isn't just art, it's a stone-bound almanac, blending symbolism with precise celestial observation. Across the ancient world, megaliths whisper this same duality. They were canvases for the sacred and ledgers for the scientific, often at the same time. Consider the Gavrinis cairn in France, its chamber walls covered in intricate carvings of axes, snakes, and zigzagging lines. At first, these appear purely symbolic, until you notice how the patterns cluster around points where sunlight penetrates during equinoxes, as if the stones themselves were reacting to the sun's touch. Or take the Babylonian Kudaru stones, etched with constellations alongside images of gods, suggesting that to ancient minds, the stars weren't just objects to study, they were divine messengers. This fusion of science and spirituality wasn't a contradiction. It was the natural order. The moon governed tides and harvests, but it also represented deities. Tracking its cycles wasn't just practical, it was prayer. The animal carvings adorning megaliths deepen the mystery. At Gobekli Tepe, vultures stretch their wings across pillars, their beaks pointing to specific stars. Some researchers interpret these as star maps, while others see them as symbols of death and rebirth. The truth likely lies in both. For cultures without writing, animals served as mnemonic devices. A fox might represent a season, a scorpion a constellation. The stones became layered texts where every image held multiple meanings, practical, poetic, and profound. Even abstract symbols defy simple categorization. The cup and ring marks found from Ireland to India, circular depressions surrounded by concentric grooves, might seem purely ritualistic, yet at some sites, their spacing matches lunar or solar cycles, suggesting they encoded mathematical relationships. Imagine a shaman tracing these grooves during ceremonies, their fingers following the same paths that aligned with the heavens. The act was both spiritual and scientific, a reminder that for ancient builders, the universe wasn't split into disciplines. To understand the world was to venerate it. This holistic worldview challenges modern distinctions between rational science and mystical belief. The Mayans, for instance, tracked Venus's cycles with astonishing accuracy, not just to predict its movements, but because they saw its appearances as omens. Similarly, Egypt's temple astronomers didn't merely chart stars. They believed the sky was a mirror of the Nile's floods, a cosmic blueprint guiding earthly life. The stones they raised weren't cold calculators. They were living bridges between the measurable and the divine. Perhaps the most poignant example lies in Brittany's Lochmariaca megaliths, where a massive broken menhir once stood. Its surface was carved with a serpentine wave pattern, echoing the nearby ocean's tides, a nod to both the moon's gravitational pull and the local myth of a sea deity. When the stone fell, it fractured along the carvings, as if the symbols themselves held the key to its structure. That's the essence of megalithic thinking. Every line, every curve, was a conversation between the tangible and the transcendent. The stones didn't just record knowledge, they embodied it, proving that the first scientists were also poets, and their laboratories were cathedrals of earth and sky. Consider the sheer scale of effort behind a single megalith, hundreds of people hauling stones for miles, shaping them with stone tools, coordinating under the scorching sun or driving rain. This wasn't just construction, it was civilization in action. When societies poured generations of labor into these monuments, they weren't merely chasing celestial accuracy or engineering marvels. They were forging something far more intangible, a shared identity. The act of building may have been as vital as the finished structure itself. Take the case of Britain's Silbury Hill, a massive artificial mound that required over 4 million hours of labor to complete. Unlike a tomb or temple, Silbury has no chambers, no carvings, just layers of chalk and earth piled 30 stories high. Its purpose remains debated, but one thing is clear. Moving that much material required a society capable of organizing thousands of workers across decades. The hill itself might be secondary to what its construction taught the community about cooperation, division of labor, and collective purpose. Power dynamics undoubtedly played a role. In the Orkney Islands, the Brodgar Rings builders imported sandstone from quarries miles away, a logistical feat only possible with a hierarchy directing resources. Yet these projects also demanded consent. Unlike pyramids built by enslaved laborers, many megalithic sites show signs of communal participation. Feasting pits nearby, like those at Durrington Walls near Stonehenge, suggest workers were fed and celebrated. This hints at a delicate balance. Elites may have orchestrated the projects, but their authority relied on maintaining communal buy-in. The stones became both symbols of control and contracts of mutual obligation. But what about knowledge? In cultures without writing, megaliths may have served as living libraries. The Mnajdra temples in Malta align with equinox sunrises so precisely that even a slight misstep in construction would nullify the effect. Maintaining such precision across generations implies formalized apprenticeship systems where elders passed down techniques through hands-on practice. The stones weren't just teaching astronomy, they were teaching how to teach. Perhaps the most profound insight lies in failure. At Wales's Carn Godog quarry, archaeologists found partially extracted bluestones abandoned mid-process. These mistakes reveal something raw. The builders weren't infallible sages, but people learning through trial and error. Each collapsed monolith or misaligned slab was a lesson etched into the landscape, proving that megalithic societies thrived not because they had all the answers, but because they dared to ask the questions together. In the end, these monuments stand as testaments to humanity's earliest classrooms, where the curriculum was carved in stone, and the final exam was survival itself. We've reverse-engineered pyramids, decoded ancient calendars, and even recreated Neolithic tools, yet some megalithic techniques still defy explanation. Take the precision of Peru's Sacsayhuaman fortress, where zigzagging walls fit together so tightly you'd swear they were laser-cut. The stones aren't just stacked, they're sculpted with concave and convex surfaces that interlock like puzzle pieces, earthquake-proofing the structure. Modern engineers struggle to replicate this without computer modeling, yet the Incas left no sketches, no manuals, just the stones themselves, whispering secrets we can't quite hear. How do you teach a civilization to carve 50-ton blocks with nothing but stone hammers and patience? The answer might lie in a form of knowledge transmission we've overlooked: embodied learning. Imagine an apprentice watching a master mason tap a granite slab, listening for the subtle change in pitch that signals a hidden fracture. Over years, those sounds become a textbook, the rhythm of strikes a syllabus. At sites like Ollantaytambo, tool marks show consistent angles and sequences, evidence of standardized techniques passed down through generations, not written in ink but etched into muscle memory. Then there's the mystery of the missing tools. At Baalbek, where 1,000-ton monoliths defy logic, archaeologists have found no cranes, no pulleys, just a few crude stone rollers. This suggests the ancients might have employed perishable technologies: ropes made of hemp or sinew that rotted away, wooden sledges swallowed by time, even ice paths that melted without a trace. Experiments show wet clay reduces friction dramatically, letting small teams move massive stones. Could the real technology have been something as simple as a chant? Rhythmic coordination transforms individual pulls into collective force, turning chaos into engineering. The greatest enigma isn't the how, but the why. Why invest centuries in perfecting acoustics at Malta's hypogeum, or align Karnak stones to lunar cycles with such precision? Perhaps because these weren't just projects, they were rituals. In oral cultures, building becomes remembering. Each stone placed was a verse in an epic poem, each alignment a stanza about the cosmos. The knowledge wasn't lost, it was lived, danced, sung into existence until the very act of construction became the blueprint. What humbles us today isn't the gaps in their understanding, it's the gaps in ours. We hunt for missing tools when the greatest tool might have been the human mind, trained to see stress points in stone like a sculptor sees a statue in marble. The megaliths stand as silent tutors, reminding us that science doesn't always leave a paper trail. Sometimes it leaves a fingerprint, one pressed into rock, waiting for us to decipher its touch. Today's archaeologists don't just study megaliths, they converse with them, using tools our ancestors could never have imagined. LiDAR technology peels back layers of vegetation and soil, revealing hidden patterns invisible to the naked eye. In the jungles of Guatemala, these laser scans uncovered entire networks of ceremonial causeways connecting Mayan pyramids, proof that what we once saw as isolated structures were actually nodes in vast, intentional landscapes. Similarly, 3D modeling lets researchers virtually reassemble stones that have toppled over millennia, testing alignment theories without disturbing fragile sites. At Portugal's Almenda's cromlech, digital reconstructions showed how missing stones would have framed the equinox sunrise, transforming what looked like a random cluster of rocks into a precise celestial calculator. Archaeoastronomy takes this further, blending astronomy with anthropology to read the stars through ancient eyes. When researchers at Colorado's Chimney Rock studied lunar standstill alignments, they didn't just map angles, they considered how the moon's silver light would have washed over ritual spaces, how shadows crept across carved spirals at dawn. This isn't cold data analysis, it's sensory archaeology, reconstructing how knowledge was experienced, not just recorded. Even particle physics gets involved. Muon tomography, a technique borrowed from volcano monitoring, now peers deep into Egyptian pyramids, revealing hidden chambers by tracking cosmic rays that pass through stone. Yet for every mystery solved, new puzzles emerge. When ground-penetrating radar detected a 20-meter void beneath Giza's Great Pyramid, it didn't provide answers. It reignited debates about the structure's purpose. Similarly, acoustic studies at Malta's Hal Saflieni hypogeum confirmed the chamber's resonance frequencies, but we still don't know why Neolithic builders prioritized sound engineering with such precision. The stones yield their secrets grudgingly, often showing us how little we truly understand. What's remarkable isn't just the technology, it's the humility it inspires. Modern science confirms that many megalithic intuitions were shockingly accurate. The Maya's long count calendar, once dismissed as myth, tracked celestial cycles WITH Chinese letter Chinese letter Chinese letter Chinese letter MODERN Chinese letter Chinese letter Chinese letter. The sarsen stones at Stonehenge display weathering patterns that match 1,000-year climate records, proving builders selected materials for durability, not just symbolism. These weren't primitive guesses, they were observations refined over generations, encoded in architecture because writing didn't yet exist to preserve them. The real revelation: we're not so different from those ancient engineers. When NASA scientists design moon landers, they too rely on trial and error, on collective problem solving. The same human impulse that aligned Karnak stones to the stars now guides rovers across Martian terrain. Perhaps megaliths were never meant to be fully understood, not as puzzles to solve, but as mirrors reflecting our enduring need to reach beyond what we know, using whatever tools the age provides. The idea that extraterrestrials guided the construction of megaliths has captured imaginations for decades. Proponents point to the near supernatural precision of sites like Puma Punku, where andesite blocks were cut with such exacting angles that they interlock like machine parts. Or Baalbek's 1,000-ton foundation stones seemingly placed by giants. The allure is understandable when faced with the inexplicable. It's tempting to attribute it to otherworldly intervention. But look closer, and a different story emerges from the stones themselves. At Egypt's Aswan quarries, the unfinished obelisk lies frozen mid-creation, its sides scarred by trial and error extraction attempts. Nearby, workers' stone pounders litter the ground, each dent in the granite recording countless hours of human labor. These aren't the artifacts of alien technology, they're the fingerprints of persistent experimentation. Similarly, Scotland's Callanish stones show multiple phases of construction, some misaligned, others corrected, revealing generations of sky watchers refining their craft. The truth is messier than ancient astronaut theories suggest. Progress wasn't linear, but a jagged climb of failures and breakthroughs. The real marvel isn't perfection, but adaptation. When Bronze Age builders at Stonehenge realized their Welsh bluestones were too fragile for traditional shaping, they pivoted, leaving natural surfaces intact and focusing on precise placement instead. At Peru's Ollantaytambo, engineers adjusted their quarrying techniques based on the pink granite's fracturing patterns, turning flaws into features. These aren't shortcuts, they're evidence of deep observational science, of humans learning to collaborate with stone rather than conquer it. What the alien hypothesis overlooks is the sheer diversity of megalithic cultures. Compare Japan's dolmens, stacked like uneven tables, with the geometrically precise sarcens of England. Each reflects its builder's unique relationship with materials and cosmology. If extraterrestrials provided a universal blueprint, why don't all megaliths share identical designs? The variations speak to something profoundly human, local solutions to universal questions, shaped by landscape, tradition, and hard-won knowledge. Perhaps the most compelling argument for human ingenuity lies in the tools we've rediscovered. At Karnak, researchers found stone mauls with wear patterns matching the granite menhirs. In the Orkneys, bone chisels still bearing microscopic polish were excavated near the Ring of Brodgar. These humble instruments, wielded by calloused hands, link us directly to the builders, not as passive recipients of alien wisdom, but as active problem solvers. The megaliths don't whisper of visitors from the stars. They roar with the collective intelligence of thousands of ordinary people, each adding their piece to an epic, earth-bound puzzle. In the end, the ancient astronaut debate reveals less about the past than about us. Faced with the extraordinary, we sometimes forget how extraordinary humans can be. The stones stand not as proof of outside help, but as monuments to what happens when curiosity, time, and communal effort converge, a reminder that the line between the impossible and the achievable is often just persistence carved in rock. Long before archaeologists arrived with their measuring tapes and theories, the stones spoke through stories. Across Europe, legends whispered that megaliths were the work of giants, petrified beings who once strode the earth, tossing boulders like pebbles. In Cornwall, locals claimed the Merry Maiden Stone Circle was a group of dancers turned to stone for daring to dance on the Sabbath, the massive dolmens of Korea's Ganghwa Island. According to folklore, they were tables left behind by heavenly kings who descended to feast among mortals. These tales weren't just idle fantasy, they were cultural memory, a way to make sense of the impossible scale and mystery of these ancient sites. The magic didn't stop at giants. In Ireland's Boyne Valley, Newgrange was said to be the home of the god Ingenious, who could make time stand still, a poetic echo of the tomb's solstice light phenomenon. Brittany's Karnak alignments were mythologized as a Roman army frozen by the wizard Merlin. What's striking isn't just the creativity of these stories, but their persistence. For centuries, with no knowledge of astronomy or engineering, communities kept the stones alive in oral tradition, attributing their construction to supernatural forces because human achievement seemed too humble an explanation. Yet hidden in these myths are kernels of practical truth. The Basque legend of the Gentilac giants who built dolmens before vanishing specifically mentions they fled when the clouds brought the first rain. Some scholars interpret this as a foggy memory of climate change disrupting Neolithic societies. Similarly, Aboriginal stories about Australia's standing stones describe their use as meeting places or songlines, preserving their social function long after the builders vanished. The stones became more than monuments. They were narrative anchors, tethering communities to their past even as meanings blurred. This blending of myth and memory reveals something profound about human nature. Faced with the awe-inspiring, we reach for the divine, but we also preserve. The very act of storytelling became a way to safeguard the importance of these sites, ensuring they weren't forgotten even when their original purpose faded. Today, as modern science peels back layers of mystery, the old tales still linger, reminding us that every megalith holds two histories, one written in alignments and tool marks, the other in the whispers of those who refused to let the stones fall silent. Time is the one force even megaliths can't withstand forever. The same rains that nourished the crops of ancient builders now seep into mortarless joints, freezing and expanding until stones shift out of alignment. At Scotland's Clogher cairns, 5,000 years of weathering have rounded once sharp edges, blurring carvings into ghostly impressions. Coastal sites face even greater threats. Rising sea levels gnaw at Orkney's Scarabrie, while salt spray slowly dissolves the limestone of Malta's temples. But erosion isn't the only enemy. The footsteps of millions of visitors compact the earth around Stonehenge, destabilizing the very ground these monoliths stand upon. In Cambodia, the sweat and breath of tourists inside Angkor Wat's chambers accelerate the decay of delicate bas-reliefs, their microbial exhalations forming acidic films on ancient stone. Conservationists walk a razor's edge. At Ireland's Brú na Bóinne, timed ticketing and restricted access protect Newgrange's solstice alignment from overcrowding, yet limit public engagement with this masterpiece. Some solutions are ingenious. Belgium's Waris megaliths now sport nearly invisible microcrystalline wax coatings that repel graffiti while letting the stones breathe. Others spark debate, like the controversial concrete repairs at Peru's Sacsayhuaman, where modern materials buttress Inca walls in jarring contrast. Even well-intentioned efforts can backfire. When archaeologists re-erected fallen stones at England's Observatory in the 1930s, they accidentally misaligned some by mere inches, a tiny error that distorts celestial sightlines carefully calibrated over millennia. The stakes couldn't be higher. These aren't just rocks, they're the only surviving manuscripts of preliterate cultures. Each lichen-cracked surface holds data about ancient climates, trade routes, and engineering techniques. At France's Karnak, laser scanning recently revealed previously invisible tool marks that unlocked the quarrying methods used 4,000 years ago. But such discoveries rely on fragile evidence that disappears when stones are cleaned too aggressively or moved without proper documentation. Perhaps the greatest challenge lies in changing perceptions. Local communities sometimes view megaliths as obstacles rather than treasures. In rural India, farmers occasionally dismantle dolmens to clear fields, unaware they're destroying ancient calendars. Educational programs now train villagers as site guardians, combining traditional knowledge with conservation science. In Sweden, school children play megalith keeper games that teach the fragility of these monuments through hands-on replicas. The goal isn't to lock the past away, but to find ways for living cultures to coexist with stone archives, because the true test of preservation isn't just protecting these sites for tomorrow, but keeping their lessons alive in the people who live beside them today. Theories about how ancient people moved massive stones are just that, theories, until someone actually tries to do it. That's where experimental archaeology comes in, a field that turns speculation into sweat, blisters, and sometimes startling revelations. Take the case of Easter Island's Moe. For years, scholars assumed islanders dragged the statues horizontally on wooden sledges, but when teams attempted this with full-scale replicas, the results were disastrous. Stones gouged deep trenches, ropes snapped under tension, and replicas cracked under their own weight. Then came a breakthrough. Researchers tried walking the statues upright, rocking them side to side with coordinated rope pulls. To everyone's astonishment, a small team could move a 10-ton Moe hundreds of yards in a day, no sledges required. The experiment didn't just solve a logistical puzzle, it revealed a deeper truth about ancient ingenuity. The statues' designs, their forward-leaning posture, curved bases weren't just artistic choices, they were engineering solutions, turning each nudge into momentum. Similar experiments have reshaped our understanding of Stonehenge. Using only Neolithic tools, volunteers quarried, shaped, and transported sarsen stones, discovering that wooden sledges on greased log tracks could move 30-ton blocks at a pace of 1 mile per week. But the real surprise came when they tried raising the stones. By digging tapered pits and tilting monoliths into place with levers, teams found that the iconic trilithons, those towering arches, could be assembled with just 20 people and a lot of patience. These trials expose a myth of their own, that megaliths required supernatural skill or lost technology. The truth is simpler and more profound. Ancient builders worked with the materials and physics available to them, refining techniques through generations of trial and error. Not all experiments succeed, and that's where the real learning happens. When a team in Wales tried replicating the transport of Stonehenge's bluestones, they found the stones fractured under stress until they realized Neolithic quarry workers likely selected stones with natural cleavage planes, splitting them along pre-existing weaknesses. Elsewhere, attempts to carve granite with stone tools initially seemed impossible until researchers rediscovered the power of abrasion. Hours of grinding with sandstone rods could shape even the hardest rock. These failures are gold mines of insight, proving that ancient knowledge wasn't just about brute strength, but about observing and exploiting natural properties. The most compelling experiments blend archaeology with anthropology. At Japan's Asuka quarries, teams recreated the carving of massive stone sarcophagi using traditional chisels and fire setting, heating rocks before dousing them with water to fracture the surface. But they didn't stop there. By analyzing tool marks and labor hours, they calculated that a single sarcophagus required 6 months of work by a dedicated team. This revelation transforms these stones from mere artifacts into social contracts, hinting at the organized labor and shared purpose that bound ancient communities together. What emerges from these experiments isn't just a manual of ancient techniques, but a portrait of the people who developed them. The builders weren't mystics or aliens. They were problem solvers, collaborators, and keen observers of their world. Every rope burn, every cracked replica, every sunburned volunteer struggling with a stone lever brings us closer to understanding that the true marvel of megaliths isn't how they were built, but who built them, ordinary humans armed with nothing but time, teamwork, and an extraordinary willingness to learn from the stones themselves. The silent stones that have stood for millennia are finally beginning to speak, not in whispers, but in data streams. Cutting-edge technologies are peeling back layers of time with precision our ancestors could never have imagined. Take isotope analysis, a technique that reads the chemical fingerprints locked inside rock. By tracing the unique mix of elements in a megalith's granite or sandstone, scientists can now pinpoint quarries hundreds of miles away, reconstructing ancient trade routes like detectives following a trail of stone breadcrumbs. In Cornwall, researchers recently matched Stonehenge's bluestones to specific outcrops in Wales' Preseli Hills, but with a twist. The stones weren't taken from the nearest or easiest sources. Some were hauled from hidden valleys, suggesting these locations held sacred significance beyond mere convenience. Artificial intelligence is cracking even tougher puzzles. Machine learning algorithms now scan thousands of tool marks on megaliths, detecting patterns invisible to the human eye. At Turkey's Karahan Tepe, AI identified consistent strike angles across hundreds of pillars, revealing standardized carving techniques passed down through generations. Other programs simulate how sound waves would have bounced off Malta's hypogeum's walls 5,000 years ago, before erosion altered their acoustics. The results: certain chambers may have amplified specific frequencies to induce trance states, a theory that could explain the site's labyrinthine design. But the real game changer is LiDAR paired with neural networks. In Mexico's Maya lowlands, this combo recently uncovered a sprawling network of hidden causeways connecting ceremonial centers. The AI flagged subtle elevation changes in the jungle canopy, inconspicuous to humans but betraying ancient roadways beneath. Similar surveys in Britain's Stonehenge landscape revealed previously unknown processional routes aligned with solstice sunrises. These aren't just new discoveries, they're reshaping our understanding of how megalithic sites functioned as interconnected ritual landscapes rather than isolated monuments. Yet every answered question births new mysteries. Advanced 3D modeling of Peru's Sahuite stone exposed intricate hydraulic channels too precise for hand tools, yet no metal implements have been found nearby. Could the builders have used some lost technique, like acid etching or high-temperature fracturing? Meanwhile, DNA analysis of skeletal remains near megaliths uncovers surprising genetic links. The builders of Ireland's Newgrange shared ancestry with Anatolian farmers, while Brittany's Karnak populations show markers from the Pontic steppe. These stones weren't just local projects, they were nodes in a vast, interconnected Neolithic world. The coming decade promises even more revelations. Quantum sensors may soon detect buried megaliths by reading disturbances in Earth's magnetic field, while nanoscale imaging could reveal pigments or residues long faded from carved surfaces. But perhaps the most exciting frontier is participatory archaeology. Citizen scientists worldwide now upload drone footage to global databases, where algorithms scan for undiscovered alignments or eroded carvings. A teenager in Portugal recently spotted a previously unnoticed solstice alignment at her local cromlech using nothing but a smartphone app. What emerges isn't just a clearer picture of the past, but a humbling lesson in humility. The more we learn about megaliths, the more we realize how much ancient builders achieved without our modern arrogance. Their primitive tools were perfectly adapted to their needs, their superstitions grounded in meticulous observation. As our machines decode their secrets, we're not just uncovering their history, we're rediscovering the boundless potential of the human mind when it engages deeply with the world. The stones have been waiting 5,000 years to share their stories. Finally, we're learning how to listen. Megaliths don't just tower over landscapes, they tower over time itself, bridging the gap between ancient minds and our own. What's astonishing isn't just what these builders achieved, but how their struggles mirror ours today. Take the blue stones of Stonehenge, hauled from Welsh quarries over 150 miles away. Modern engineers have calculated that moving just one of these 4-ton monoliths would have required hundreds of people working in perfect harmony, adjusting ropes, swapping out rollers, navigating treacherous terrain. Sound familiar? It's not so different from the teamwork behind a SpaceX launch or the coordination needed to build a skyscraper. The tools have changed, but the human instinct to collaborate on grand projects hasn't. What's even more striking is the shared language of problem solving. When the builders of Malta's Hal Saflieni hypogeum discovered that certain chambers amplified sound at specific frequencies, they didn't just shrug and move on. They refined the architecture, carving niches and channels to enhance the effect. That's the scientific method in its purest form: observe, hypothesize, test, refine. No lab coats, no textbooks, just stone and persistence. Halfway across the world, the Maya were doing the same thing at Chichen Itza, where the steps of El Castillo pyramid chirp like a Quetzal bird when clapped. These weren't accidents, they were experiments, proof that curiosity isn't a modern invention but a primal urge. The stones also teach us about failure and its unexpected gifts. At Karnak, some menhirs lie toppled, their alignment slightly off. In Peru, an unfinished obelisk cracks mid-carving, abandoned in its quarry. These mistakes are just as revealing as the successes. They show us builders willing to take risks, to push materials to their limits, to learn from collapse. Imagine the first time a capstone slipped during dolmen construction, shattering on impact. Rather than giving up, they adapted, maybe by notching the supporting stones or adjusting the angle of pull. That iterative process, that refusal to see failure as final, is the bedrock of innovation. Perhaps the most humbling lesson is about scale. We live in an age of instant gratification, where answers are a click away. But megaliths remind us that some truths unfold over generations. The solar alignments at Newgrange weren't perfected in a year or even a lifetime. They required centuries of observation, of elders pointing to the horizon and saying, "Watch where the light falls." In an era before written records, knowledge was a baton passed hand to hand, each runner adding their stride to the relay. That long-term thinking, planting trees whose shade you'll never sit under, is a muscle we've atrophied, and one these ancient cultures exercised daily. And then there's the poetry in their practicality. The same stones that tracked solstices also hosted burials. The same alignments that predicted harvests framed rituals. For them, science and spirituality weren't opposing forces but two sides of the same carved menhir. When we marvel at the precision of Egypt's star shafts or the acoustics of Scotland's Ring of Brodgar, we're seeing more than engineering. We're seeing a worldview where understanding the universe was inseparable from honoring it. That's why these sites still move us. They're not just feats of strength, they're acts of reverence, proof that the drive to measure the heavens is also, always, a longing to touch them. So the next time you pass a modern observatory or a physics lab, remember, its roots run deep, all the way down to the first person who stacked 2 stones to mark the sunrise. The tools have grown sophisticated, but the questions remain the same. How does the world work? How can we shape it? And most importantly, how do we pass that understanding forward? The megaliths whisper the answer, stone by stone, observation by observation, generation by generation. They remind us that science isn't just about data, it's about legacy. And that's a lesson carved not just in rock, but in the very core of what makes us human. Hollywood loves a good mystery, especially when it involves ancient megaliths and alien architects. But strip away the dramatic special effects, and you're left with something far more extraordinary: the real sweat and calluses story of human ingenuity. Take the infamous precision-cut stones of Puma Punku in Bolivia, often cited as proof of lost technologies or extraterrestrial intervention. On screen, these andesite blocks fit together like a 3D puzzle, their razor-sharp edges seemingly impossible for primitive tools. Yet archaeology tells a different tale. Recent experiments with copper chisels and abrasive sand proved that patient artisans could achieve those flawless joints, not in days, but over months of painstaking grinding. The real magic wasn't alien lasers. It was generations of craftsmen honing their skills, passing down techniques like living textbooks. Then there's the persistent myth of the impossible Baalbek trilithon. Those 1,000-ton foundation stones in Lebanon supposedly too massive for human hands. The truth, Roman engineers later repurposed these megaliths, but their original builders left clues in the quarry itself. Half-finished blocks still attached to bedrock reveal a low-tech secret. Workers carved trenches around each stone, then cracked them free using wooden wedges soaked in water to expand the rock. Transport was a feat of physics, not fantasy, likely involving sledges, rollers, and armies of laborers coordinating like a well-oiled machine. The real marvel isn't how they moved these stones, but how they organized entire communities around such audacious projects without modern hierarchies or blueprints. Even the astronaut carvings at Peru's Nazca lines crumble under scrutiny. Some claim these desert geoglyphs were landing strips for spacecraft, yet ground surveys show they align with ancient pilgrimage routes and groundwater sources. The figures a hummingbird, a spider mirror constellations important to farming cycles. This wasn't extraterrestrial graffiti. It was a massive, walkable almanac designed to guide rituals tied to survival. Similarly, Egypt's pyramid energy vortexes dissolve when you examine the actual limestone block's ordinary rock, with no special properties beyond superb engineering. The danger of these myths isn't just that they're wrong, it's that they steal credit from the true innovators. When we attribute megaliths to aliens or Atlanteans, we erase the indigenous knowledge systems behind them. The Maya didn't need crystal skulls to build observatories. They had millennia of celestial observations encoded in oral traditions. Britain's Neolithic farmers didn't require Merlin's magic to align Stonehenge. They used simple marker sticks and generations of solstice sightings. These cultures weren't primitive, they were pioneers, turning landscapes into laboratories where trial and error yielded astonishing precision. That's not to say mysteries don't remain. How did Rapa Nui Islanders place red stone hats on Easter Island's moai, some weighing 12 tons? Why do certain Karnak stones emit ultrasonic frequencies? But here's the key. Gaps in our knowledge aren't proof of the supernatural, they're invitations to dig deeper. Every time LiDAR reveals a hidden causeway or isotope analysis traces a bluestone's origin, we're reminded that the truth is often stranger and more human than fiction. The real story of megaliths isn't about lost civilizations or cosmic visitors, it's about us. Our curiosity, our resilience, our unshakable drive to reach beyond what seems possible and leave a mark that echoes through millennia. And that, more than any myth, is worth marveling at. As we stand in the shadow of these ancient stones, their silent presence speaks volumes about the ingenuity and resilience of the people who shaped them. These megaliths are more than just relics of the past, they are living testaments to humanity's first steps into the realms of science, engineering, and collective memory. From the solstice-aligned corridors of Newgrange to the celestial grids of Karnak, every stone carries the fingerprints of curiosity, patience, and an unshakable drive to make sense of the world. What's truly remarkable isn't just the precision of their alignments or the audacity of their construction, it's the universality of their purpose. Whether marking the turn of the seasons, honoring the dead, or capturing the rhythms of the cosmos, these monuments reveal a shared human impulse to reach beyond the tangible and touch something timeless. The builders of Gobekli Tepe didn't just stack stones, they encoded their understanding of the stars into pillars. The engineers of Machu Picchu didn't just fit rocks together, they crafted earthquake-proof puzzles that still baffle modern architects. These weren't isolated acts of genius, they were chapters in a global story of discovery, written in the language of earth and sky. Yet for all we've uncovered, the stones still guard their deepest secrets. How did scattered cultures, separated by oceans and millennia, arrive at such similar solutions? What lost techniques allowed the movement of 1,000-ton blocks without modern machinery? And what stories, songs, and rituals have faded into silence, leaving only silent monoliths behind? The beauty of these mysteries is that they refuse to surrender all their answers, inviting us to keep questioning, exploring, and reimagining the past. Perhaps the greatest lesson the megaliths teach us is humility. In an age of instant answers and digital certainty, they remind us that knowledge is often slow, hard-won, and built layer by layer, just like the stones themselves. The builders didn't have all the tools we do, but they had something just as powerful: observation, perseverance, and the courage to dream big enough to shape landscapes. Their legacy isn't just in the alignments we can measure or the tools we've rediscovered. It's in the unbroken chain of curiosity that connects their world to ours. So the next time you see a standing stone or read about a newly uncovered dolmen, take a moment to wonder not just how it was built, but why. What drove someone thousands of years ago to carve, haul, and raise these giants? What did they hope to tell us across the centuries? The answers might still be hidden in the stones, waiting for the next generation of explorers to listen. Now it's your turn. Which megalithic site leaves you in awe? What unanswered questions keep you up at night? Drop your thoughts below. We're all part of this conversation, just like the builders who came before us. And if you've enjoyed this journey into the dawn of science, don't forget to subscribe. There are always more secrets waiting to be uncovered, and we're just getting started.